Hello and welcome back to the Master Civil Engineering. In this video, you will learn that how to find the length of the sag vertical curve according to the AASHTO's guidelines. I have been given a question which states that a highway is being designed to the AASHTO's guidelines with 65 miles per hour design speed, and at one section an equal tangent sag vertical curve must be designed to connect grades of minus 2.5% and plus 2%. We have to determine the minimum length of the curve necessary to meet the SSD requirements at night time. Okay, so for the sag vertical curve, the critical concern is the length of the roadway that is illuminated by the vehicle's headlight. Okay, and it is in turn a function of the head of the headlight above the roadway and the inclined angle of the headlight beam. Okay, we will see this in the AASHTO's formula. Okay, so design speed for our question is 65 miles per hour, which is equal to 95.33 feet per second. Initial grade is minus 2.5%, final grade is plus 2%. Absolute difference of grade is minus 2.5 minus 2, which is 4.5%. Stopping side distance given by AASHTO's formula is v into t plus v square divided by 2g bracket a by g plus minus g. Okay, v is the design speed, which is 95.33. T is the perception reaction time, which is 2.5 second. Okay, g is the acceleration due to gravity. Okay, a is the deceleration rate, which is 11.2 feet per second square, and g is the gradient of the road, which in our case is 0. So this small g and small g will cancel. So in denominator for the second term, we will be left with 2a. So it will be 2 into 11.2. So SSD for our problem is 644.03 feet. Okay. Now AASHTO has given two formulas for the minimum length of the sag vertical curve to provide the necessary SSD requirement at night time. You have to assume either the length of the vertical curve is greater than or the smaller than SSD. So first we will assume that our length of the curve is smaller than SSD, and for this the minimum length of vertical curve according to the AASHTO's formula is 2 into s minus 200 into h plus s into tan of beta divided by a. Okay, so where this s is the SSD, it is equal to 644.03 feet. H is the height of the headlight, which is 2 feet according to the AASHTO. B is the inclined angle of the headlight beam, which is 1 degree. Okay, and A is the absolute difference of grade, which is 4.5%. Okay, putting values in the equation, we get the minimum length of the vertical curve equal to into 644.03 minus 200 into 2 plus 644.03 into tan of 1 divided by 4.5, which is equal to 699.5 feet. We can see this is greater than the SSD. Our SSD, that is the stopping side distance, is 644.03. We assumed that length of the curve will be less than SSD, but here it is coming greater than the SSD, so our assumption is wrong. It means that the length of the vertical curve, sag vertical curve for this problem is greater than the SSD, and for that there is another formula given by the AASHTO, which is L is equal to AS square divided by 200 H plus S into tan of beta. This formula is valid when the length of the vertical curve is greater than the stopping side distance. Okay, again you have to put same values in this equation, that is A is 4.5, S is 644.03 divided by 200. 2 is the height of the headlight plus 644.03 into tan of 1. This gives me the value of length of vertical curve equal to 704.8 feet. You can see this is clearly greater than the SSD, so our assumption now is correct, that the length of the vertical curve is greater than the SSD. So you can say that the minimum length of the sag vertical curve to provide SSD at night time for this problem is 704.8 feet. Okay, so this is how you can calculate the length of the sag vertical curve to provide necessary SSD at night time according to the AASHTO. Okay, I have also made a solution video of how to find the minimum length of crest vertical curve to provide the SSD. Okay, you can also check that video. I hope this solution video was clear and effective, and if you found this video helpful, you can subscribe to my channel, share this video. Okay, thanks for watching and stay tuned.